Hi everybody, it's time for Science Notes. Today we're going to talk about math in science. Let's get started. By the end of this lesson, you will describe what math skills scientists use in collecting data and making measurements, and identify the math tools scientists use to analyze their data. So what math skills do scientists use? When collecting data, scientists use math skills that include estimation, accuracy, and precision, and significant figures. Let's look at each of these individually. Estimation. An estimate is an approximation of a number based on a reasonable assumption. Look at this rice. It's a lot of rice. Would you stop and count every single grain of rice in this bowl? Or could you try to come up with an estimate? If you decided to come up with an estimate, how would you go about doing that? Accuracy. Accuracy refers to how close the measurement is to the true or accepted value. So let's say someone actually does count every single grain of rice in this bowl. And then they handed the bowl to someone else. Could that person count the exact same number of rice grains? If they do get close enough to the accepted value, they're being accurate in their counting. This is different from precision. Precision refers to how close a group of measurements are to each other. So, the two people stop and count every single grain of rice. They come up with two or three different numbers. One number's way off, another one's close, the others are right on the money. How precise are they? How accurate are they? There's another way to determine how many grains of rice are in this bowl. If we used a high precision scale or balance, we could find out the mass of just one grain of rice. Once we determine how much one grain of rice weighs, we could then use estimation to come up with how many pieces of rice are in the bowl by measuring and weighing the entire bowl of rice. Significant figures. Measurements are never completely precise. There really isn't a way to always know exactly how much this bowl of rice weighs and how many pieces of rice are in this bowl. It all depends on which grain of rice we decide to measure and weigh. It depends on if we lose one or two along the way, etc. If we're doing several measurements of this rice, we can use significant figures to communicate how precise our measurement is. We can get within 1/100th of a gram, 1,000th of a gram, even 1 millionth of a gram, depending on how precise and high precision our instruments are. So, what math tools do scientists use? Scientists use many math tools to analyze data. Some tools include mean, median, mode, and range. Scientists also use percent error and other math tools to determine if the value of data points are reasonable. Let's look at these individually. The mean is the numerical average of a set of data. So let's say we have a set of data, 4 numbers. We add them up, we get a total. We then take that total and divide it by the number of numerals in that set, in this case 4. 4 goes into 10 twice. 4 goes into 20 5 times. In this case, our average, or our mean, is 2.5. A median is the middle number in an ordered set of numbers. If you have an odd set of numbers, as in this case, the median number is just the number that's right up the middle. In this case, the number 4. If you have a set of numbers that are even numbered, like this set, in order to find the median, you would take the 2 center numbers, add them together, and then divide by 2. In this case, the median is 4.5. The next math tool that scientists use is mode. Mode is the number that appears most often in a set of numbers. In this case, the number 2. The range of a set of data is the difference between the largest or greatest value and the least value. In this case, the largest value is 10, the least is 1. The difference will be to simply subtract them. This is the range, 9. Anomalous data is data that does not fit the data set. Let's say you're collecting data. You're measuring something, and you're getting numbers that are pretty much the same, except for one number. Why is that number wrong? You have no idea, but you need to find out. This number is anomalous. It does not fit the data set. Finally, we have percent error. Percent error is the percent difference between the known value of a substance and the measured value. So let's look at our bowl of rice again. Let's say that I know the true value, or exactly how many grains of rice are in this bowl. And let's say I have you actually count out or measure in some other way how much rice is in this bowl. We can determine how close by percentage you are to the true value. There's an equation for that. The percent error would equal your value, which is the experimental value, minus mine value, which is the true value. Take those two numbers and divide them by the true value. The percent error then would equal this new number times 100%. Let's review. The math skills that scientists use include estimate, accuracy, precision, and significant figures. The math tools that scientists use would include mean, median, mode, range, anomalous data, and percent error. Thanks for watching. Have a great day.